Alright, so in question number 5, let's try to be practical and let's try to do these questions the way that a bank would do these questions. In other words, let's do them efficiently. When we read these questions, we should always look for the word compounded and look for what kind of compounding. Generally speaking, you'll have two types of compounding, and I'll make this as a little note that you can transfer to your notes later on. The first type of compounding that you'll see in this question is compounding continuously. If you see the word continuously, make a note to yourself, that's where you're going to use the PERT equation. If you see any other sort of compounding, so that's usually compounding by what we call a set frequency. A set frequency would be things like annual, quarterly, monthly, etc. If it's something for which you would say to yourself, oh, I know exactly how many times a year that's going to happen, that's when you use the fancier formula, 1 plus r over n to the power of n times t. Now, of course, you'll always have your notes accessible to you. You don't ever have to memorize these formulas. So it's worth it to just make a little note to yourself, a little cheat sheet, for example, so that you have it for reference. But these are the two types of compounding problems you're going to encounter on the next page, and it may be worth having a little note to yourself so that you know when you read the question what keywords to pay attention to. If I read question number 5, we've got this guy investing the same principal amount, so assuming it's the same guy from the whole page, in an account offering 2% annual interest compounded continuously. There's that word, continuously. That's telling me this is going to be a PERT problem. So that's the word association you can immediately start to make. As soon as you see the word continuous, think of the PERT formula. For the PERT formula, I need to identify P, which is my principal, R, my percentage interest rate, and T for time. So let's read the question again for that information. Same principal amount. I assume they're talking about the previous questions. That principal amount was $10,000, which I assume they're still referring to. So that's going to be P, 10,000. 2% annual interest. That's my interest rate. Remember, we just have to call it a decimal, so 0.02. 25 years is obviously a value of time, so that's my T. So now I have the three numbers that I need for the PERT equation. Remember, E is a number that's pre-stored into your calculator. You do not have to memorize it as a number. You can just use the button in your calculator and it will store that number for you. It's 2.718, but if you don't want to memorize it, it's no big deal. So let's do this. We have P, 10,000. E, already a number. We'll just leave it as E. To the power of R, 0.02, times T, 25, and I'll type that into my calculator. I have 10,000 E, sorry, you can't see that, to the power of, parentheses, 0.02 times 25 years, 16,487 and 21 cents. Let's just read the question. It says, will he earn more money than he would in the scenario in number 4? Remember, in number 4, he earned $14,918. 16,000, it does appear that he's making more money, so we would say confidently, yes, he will earn more money. Now, it is interesting if you delve a little bit deeper in this question. He's earning a smaller interest rate. He's only getting 2% interest in this one, but the difference is he's compounding for 25 years. Compare that to the table. In question number 3, he had a better interest rate, 4%, but he was only going for 10 years. So you might remember in the previous lesson where I mentioned that the biggest kicker with these problems is time. The longer you let your money compound, the more you're going to end up getting. Time is the biggest variable in these problems. It's a bigger variable than any of these other ones. It makes the biggest difference mathematically. Now notice again, speaking of time, how much more efficiently we can do the PERT problems once we know what to plug in. P is principal, R is rate, T is time. Plug everything in, your calculator does the work. Both formulas that we're going to use are equally useful for that reason. We can just quickly plug things in and our calculator can do the work for us. So hopefully now that you've seen these two different types of compounding, you can start to think about what it's going to take on page 18 to apply those formulas in different contextual situations.